Okay, we're going to look at analyzing quadratic functions with a graphing calculator in this lesson. So we're going to graph both of the examples, y equals x squared and y equals 5x squared, and then they ask us here to make a sketch and comment about the differences between the two. So I've already got x squared and 5x squared in here. So you would sketch this. I'm actually just going to paste it in, but you would need to sketch it. So if we label them, we want to label them appropriately. So that one is x squared, and in red here, this one would be the 5x squared. Now remember, in your calculator, if you want, you can make one of them thicker so you can tell the difference. So I left arrow over there and highlight that slash line, hit enter once, and it makes that one thicker. So the 5x squared in the graph now over here on the screen will be the thick one. So you can tell the difference. That's usually a good thing to do. So now we want to comment on it. Well, the second graph, we could label it this way: y1 equals x squared, y2 equals 5x squared. So we could say that y2 is thinner, or y2 is thinner than y1. That's fine with me if you use that. You could also say 5x squared is thinner than x squared. That would be fine too. Okay, let's look at the second example. Okay, so now looking at example 2, y equals x squared, same as before, and x plus 2 quantity squared minus 4. So I've got those in. I'll graph it. I'm going to make the y2 graph thicker, make the line thicker so we can tell the difference. And then you would sketch this. Just do the best you can on your sketch. It doesn't have to be perfect. So I'm just going to paste this in here. And looking at it, the width looks about the same. They're both the same width, but this one, y2, so let's write this. y1 is x squared, y2 is x plus 2 quantity squared, subtract 4. The y2 is left 2 and down, left 2 and down 4, compared to the original, left 2, down 4. Example 3 says, find the roots of 3x squared minus 4x minus 6 equals 0. Sketch the graph. Well, we want to find where does it intercept the x-axis. X-intercepts and roots and zeros all mean the same thing. So we're looking for, paste this picture in, we're looking for these 2 points right here. So the way that we're going to do that is we're going to graph y equals 0. That's going to put a horizontal line in on top of the x-axis and find the intersection. So second trace, option 5. For the first one, I just hit enter 3 times. First curve enter, second curve enter, guess enter, and I find one of them. So this one is negative 0.897, round to 3 places, comma 0. That's the leftmost. Repeat the process. Option 5 for intersect. Second curve, first curve enter, second curve enter. Now on guess, I'm going to arrow over or type in a number that's close to this one. I've got my cursor highlighted, or my cursor on top of this one, so my guess will pick that up, and it would be 2.23 comma 0 for that one. And that's how you find the roots. Okay, this next section is talking about finding the vertex. And we know from our previous discussion that the vertex is either a minimum or a maximum. It's either the lowest point or the highest point on the graph. So if we are finding a minimum point, on our graphing calculator we're going to use second calc minimum, and that would be appropriate when the parabola is opening up like this one. We'd be finding the vertex right here. It's the minimum, it's the lowest point, so that's the appropriate way. If the parabola is opening down like this one, then the vertex is at the maximum point, so it would be up at the top. So we'll use maximum for that. So we're going to look at an example right here, and I've already put that in here. X plus 2 quantity squared minus 4, so this is our vertex form. going to graph it here and bring this graph over, and we're finding the vertex right here. So the vertex, we'll label it. So you should be sketching this. It will be a minimum. We'll just abbreviate min because it's on the bottom. So we'll do second trace, same way that we find the roots using intersection. Only this time we're going to choose either option 3 or option 4. Because this is a minimum, I'm going to choose option 3. If it were opening down, I would have chose maximum. So calculator always asks you the question that it needs you to answer. It says left bound. That means get left of the vertex. So that means on the graph somewhere over here. It doesn't have to be exact. It could be here. It could be here. It just needs to be left of the vertex. So I'm going to left arrow till I get left of it. Right there is fine. I'm definitely left of it. I could keep going, or I could be here, just somewhere left. It doesn't matter as long as you're left. So hit enter. Look right here. Always your eyes go here. Calculator asks you what it needs. Right bound. So that means get right of the vertex. So somewhere over here. Doesn't matter where, as long as it's right of the vertex. So I'm going to right arrow. Right there is fine. I could be here. I'm still right of it. I could be here. Still right of it. Could be down here, still right of it, just need to be right. So hit enter. For guess, that's fine, just hit enter. It'll find it. So you need to be aware of rounding error in your calculator. Don't write negative 1.99999. Just write negative 2. It's negative 2. Negative 2, comma, negative 4. The vertex is negative 2, negative 4. And if you look at the function, we know that because it's moved left 2 from this right there and down 4 from there. So left 2 down 4 takes me to negative 2, negative 4. Alright, that's it for this video.